I'm going to talk here about a work that I did with a few other colleagues, Krista Chawar from West Point, Rajendra Raj from Rochester Institute of Technology, and Ed Sobiesk also from West Point. And we're going to talk about how you might take cybersecurity practices and principles and infuse them throughout an undergraduate curriculum. So my first, I'll go through and I'll talk about the challenges that we had. I'll come up with the methodology that we used and give you a few examples that we have. This is the, if you will, the confusing slide that shows all the confusion that you have when you're trying to address the many issues that you're supposed to address with respect to a computer science curriculum. And it's looking at computer science as a whole, but the challenge of trying to fit cybersecurity in our model here, you'll see by the end, is that we submit that adding a single course to get the cybersecurity into the computer science curriculum that you need is not necessary and may not be exactly what you want to do, because so many of the practices that you have in computer science are also good security practices. That's the premise of what we're doing. So here, this just tells you a little bit about the tensions, if you will, of the kinds of things that you're trying to do in a computer science curriculum. You have competing demands, the evolving disciplinary needs and what you need to put in there. You don't want to necessarily sacrifice the elective choices that the students get, and you don't want to add security concepts just on the periphery in maybe a course on networks or a course on database. That's really not where cybersecurity belongs. It belongs throughout. And then there are also challenges with bolting on a course. Is it a course that comes at the beginning so that as the students go through the whole program, they've got this idea of security baked in? Or is it something that comes at the end where you have enough of the background of computer science and you can put it in? Okay, so we're going to talk about this by saying, let's suppose that we have a traditional computer science curriculum here, and maybe we'll take the courses and rather than giving you specific courses, we'll say we have a programming thread, we have a theoretical foundations thread, we have a systems thread, and we have a computing in practice thread where you get a lot of different types of things that are going on. And you want to look at this and see, how do you add the cybersecurity principles and practices that you know that the discipline now needs. And this is, again, our premise that we don't buy into adding something on the side as another thread, but rather into this idea, if you will, that there are all these practices that we're already teaching that are good computing practices, and we believe that they're throughout the program. So that too, we think, is not quite sufficient. This is the same thing, but what we like to say that we need to add is maybe some emphasis on it, or using different terminology, if you will, as you go through the program to explicitly show the students where the security practices and principles appear. So here's our methodology for being able to do this with throughout the curriculum. First thing that we're going to do is we're going to identify the principles, and those principles may vary across the programs depending on what your constituent needs are. So first, we want to know what they are. Second step, we want to map the current curriculum that we have to those principles and see what we already have. Next step would be to identify where we might have some gaps. Fourth step is to figure out whether or not you want to fill those gaps and to what extent or how you might fill those. And then the last and most important step is to connect those principles and practices to the practices throughout the entire curriculum. So I'm going to now go through some examples that show you how to do these various steps. If we talk about step one might say, okay, maybe cybersecurity is not my particular background. I'm a computer scientist, but I don't have that. So how do I know what principles might be important? So I'll look at in this case, we looked at 6 different inputs. One was our constituent needs, and we had, pardon me, for the co-authors that we had some from West Point, and we had some from Rochester Institute of Technology. They had different constituents, so we looked at that. We looked at the most recent computer science curriculum definition and how it focused on in that what was called then information assurance, and we now call cybersecurity. We looked at the new cybersecurity curricula as it's evolved. We looked at the National Security Agency's Center for Academic Excellence in Cyber Operations and what they defined principles to be. We looked at the Open Web Applications definition of security principles. And then we looked at a modernized form of Seltzer and Schroeder's security principles. And we looked all of those through all of those, blended them together, decided what applied to our programs, and then came up with this list of 7 principles that we thought we needed to be sure were covered throughout our program. So confidentiality, integrity, and availability, open design, economy of mechanism. You gotta, for some of these, you have to look at the definitions to really know what they are. Least privilege and complete mediation, fail-safe defaults, defense in depth, and psychological acceptability. So given that we now have these as our principles that this particular program wants to look at, we do this mapping, and the details of this mapping do not matter at all. This is just showing you what's in the paper. You can see exactly this table in the paper. But what you notice is there is a column for each of the 4 threads that we chose to define. There could be a column for each of the courses that are required in a program or whatever you choose to do. And then there's a row for each of the principles. And as we went through and looked at those 6 different sources of how they might define these principles, we pulled out the aspects that already existed in the curriculum and put them into the various places. So let's just focus on the open design row that we have there. If you look at it, you might say, well, I already have all of these different concepts and practices taught within the program. So in the programming thread, for example, we teach programming comments and style and modularity and readability, variable names, abstract data types, and everything like that. That's all a part of what open design is about. And we have the others. And then, so that's step 2, is to do that mapping. Step 3 is to figure out where there might be gaps. And suppose in this example, there were gaps in these 2 spots where we talked about vulnerability analysis as a security testing technique. And then we also talk about the ethics of vulnerability disclosure. Okay, so that might be what you discover during step 3. And now I want to orient you to this that is essentially my last slide to tell you how we evolved one course to do this same kind of thing. So just as an orientation, on the left side there, you will see the calendar with the particular lessons that we had in the software testing and development course. And those lessons were divided by topics or threads through that particular course. So left side, spring semester of 2019. On the right side, the same course, spring semester of 2020, just this year. And I'm going to show you how that course evolved without changing a lot, but changing enough to really help with getting the security principles in here. What did not change, so this is a 30-lesson course. What did not change across the 2 is the development practices lessons. There were 4 lessons there. The test-driven development lessons, there are 4 of those. And then the GUI, graphical user interface programming lessons, there were 3 of them. The thing that's called a WPR or admin exams, WPR in our language is written partial review. That's just for an exam. And then we also had the project reviews where we talked with students or had them present how they were doing all of this. So those are unchanged topics from one offering to the next offering. But we took the lessons on object-oriented programming and web programming, and we refocused those topics, giving them a different language, a different terminology, if you will. But we were still getting at most of the same concepts. So now, instead of having what was labeled as 7 object-oriented lessons and 5 web programming lessons, we took one of those and added it into the test-driven development. And we took one and we added it into the GUI programming. And the other 10 are explicitly mentioned as security. And we got into and talked about the terminology of security, but we're still teaching the same concepts. So here's an example in doing that where we had a lesson. It was titled Design by Contract, as in object-oriented programming. It is now titled Economy of Mechanism, but it's doing the same thing. It's still focused on single-purpose class design and minimization of side effects. And so we just take these words and we connect them together so that the students truly understand that what it is that they're doing is good, secure programming practices. Okay, so my final thoughts here, just a little bit of a summary of what this paper is about, and I encourage you to look at the paper. It's about a methodology for discovering, if you will, all the good practices that you already have in your curriculum that are not now explicitly represented as security or known as security to either the students or your constituents, and to properly label them as security good practices, security practices, and connect them together for the students, purposely connect them together for the students so that they understand that. And then there are a few future works possibilities. So I will skip those since I'm out of time, but I am available now to answer questions and available in these other forums also to answer questions.